Okay, quick take on 7.3. Here's my thoughts. If I'm looking at this, if I saw this, I would notice first off that it's the y part that's squared. On part A here. Number one, part A, the y part is squared. It says it's y minus 2 quantity squared in my case. So if it's the y part that's squared, that means we got ourselves a sideways parabola instead of an up and down one. So if I were to start drawing this idea, we'd expect this to be like a sideways going to the right type parabola. It could go to the left, except I don't see like a negative timesing anywhere, so it's probably going to the right. And then we'll just find out where's the center of this thing, or actually where's the vertex, I should say, and then how else to draw this based on the focal diameter. And so what I would see is, okay, looking at new zeros, x minus 3 means new zero on the x-axis is positive 3, 1, 2, 3. And new zero on the y-axis for y minus 2 would be a positive 2 on the y part. So we have ourselves a vertex. That's the dot that is actually part of the parabola. It's not the focus. That's the that's the vertex that the parabola actually hits before it turns around. So we'll expect that. Maybe I'll put just a rough drawing there, even though these normally end up not going accurately until later on, because we got to look at the focal diameter to get it right. And so I'll put a mock-up drawing there. And then one other thing to notice is that indeed we have a constant 12 timesing here, and that 12 tells us a couple of things. First off, it tells us that 12, if I divide it by 4, you might remember if you watched the intuition video or if you know much about this stuff. Otherwise, if I divide this by 4, I get a 3, and that means that I'm going to have 3 steps to get from the vertex over to the focus. So that's 1, 2, 3 steps in to get to the focus. And then 3 steps to the left, or 3 steps out. 1, 2, 3 steps out. Puts us, in this case, right by the y-axis again to get to the directrix. And the directrix is a line, so we'll have this little funny line going this time. And so now there's a focus on the inside, directrix on the outside. And now we can pretty much draw this thing. Only thing that you might notice is, again, the 12 itself is beneficial for drawing these things if you ever have to. I don't think we need that here until later in the assignment, but essentially the 12 happens to tell us how far wide to open this parabola, because the 12 is, if I got 3 steps going into the focus, then it's 6 steps each way to get to the parabola itself, making a total of 12. 6 up and 6 down makes 12 steps before you hit the parabola. So this one we'd be like 3, 6, 3, 6, and we'd hit the parabola out there. Anyway, so that focal diameter is 12. Whatever. For right now, we'll just say, I think we got everything we need to know. The vertex happened at, where did the vertex happen at? Over 3 steps and up 2 steps because of the x and y thing. So that was at 3 and 2. And then the focus happened on the inside of that. And so that was 3 steps, and then another 3 steps to get to. That's 6 steps over. But it didn't go up any, so it was still 2 steps up. And the directrix was 3 steps to the left of our what is that called? The vertex. And so we have a line that's sitting right at the y-axis, which is where the x value is 0. So then we just say x equals 0. That's how I would look at that one. Now, I could have left that probably. Okay, looking at the next one, it seems like they didn't set us up quite as well for this one, because it's not looking like, in standard form or whatever we call it. And so I do notice, though, that it's the y value that's squared again. So this would be sideways. Again, the x part is not squared, although it's funny they put 3 squared at some point. We should just call it 9, I guess. But the y part is squared, so we're expecting this to go sideways again. Looks like it's going to the right because there's no negative timesing it. It won't go to the left. So I'm expecting that. We got to figure out, though, where is this vertex going to be, and that is not as obvious until we put it in standard form. So if I were to do this, guys, remember how this goes from circle stuff. I'm probably going to have to take this y squared plus 6y, complete the square with it. So I'm going to put plus some blank mystery number that'll help us out. And then equals 20x minus 9. I'm just going to call it 9 and 3 instead of 3 squared. And then whatever mystery number we put on the left, we'll have to add that to the right as well, so don't forget that. So plus, whatever box. But let's figure this out real quick. And so, once again, to complete the square, the way it always goes is we'll put the factors down. We know they're supposed to be the same guy. They both got to add up to that 6. So it's minus 3 and minus 3 if they're going to add up to 6 but be the same. Minus 3 times minus 3 is a plus 9. And then we'll put a plus 9 on the other side of the equation too. And then we have everything we want. We have y minus 3 squared equals 20x minus 9 and plus 9 becomes plus 0 or something, you could just, whatever, just 20x is fine, I guess. If you want to help that to accentuate, like, where am I going to find the vertex of this thing, you notice there's no plus or minus stuff here. It's okay to write that as 20 times x minus nothing, so you can emphasize in your own mind that the vertex is found at the x value is, the new 0 is indeed just old 0, and the y part, the new 0, is positive 3. So we have a vertex where the x part is 0, and the y part is 3, looking good. And then the focus and all that, we're going to have to find by drawing this thing. Some people do it by analysis, but it's hard to do the analysis without getting a feel for what's going on, without feeling out the function. Oops. I erased too much. And so, if we have an equation now that at this point is reading, what's it going to be? Y minus 3 squared, all of that squared equals 20x, or 20 times x minus 0. Then we could say, well, we got the vertex, that's fine. We know that it's a sideways one, so we'll draw it. Okay, the vertex is at 0 steps on the x, so we don't go over at all. And positive 3 is the new 0 on the y, so we go up 3 and over none. Okay, so we're at the dot, 0, 3. I guess maybe I'll put that again. 0, 3 is a vertex. And then we know it's a sideways to the right type parabola, so we'll expect that. But we don't know how far to go for the focus of the vertex until we look at it. And so the number 20 is timesing with our x. So remember how that goes. Same thing. If I take that 20 and I divide it by 4, we'll get 5. And so that will tell us exactly how many steps we got to go to get to the focus and the vertex. And since we know it's a sideways one, we'll go to the side, And so here we go. 5 steps to get to the focus would be 1, 2, 3, 4, 5 to get to the focus there. Dot. And then 1, 2, whoa. And then 1, 2, 3, 4, 5 the opposite way to get to the directrix, and that's a line, so we'll just draw a line up and down from there. Then we could probably say we know what the focus and the directrix are. We'll just find them, and so indeed, this focus here, what would the coordinates of that be? It's over 5, we just did that, and it's up the same amount as we were before, so that's 3, so we're at 5, 3 is the focus. And the directrix is 5 steps backwards, so that's just going to be an x value of -5. They already have the x equals part, so you could just put -5. And then if you want to draw it, we know that the focal diameter is 20 steps, so indeed, not only is it 5 steps to get to the focus, but we know that would be 10 steps each way, 10 steps down, here I'll put it in blue, 10 steps down and 10 steps up to get to the parabola from there, whatever, making it 20 steps across, My whole drawing can't fit there. Anyway, whatever. And then it becomes rinse and repeat on the other parts, and so maybe we won't do the whole details on the other ones, but I'll do part C real quick with you guys erasing. I like to erase. So, oh man, I forgot a part. There you go. All right. On part C, only the reason I would want to bring this one up is because it is in standard form, but you notice that the x part is the one that's squared. X minus 7 quantity squared equals 20 times y minus 3. This one is going to be quicker because we don't have to do the complete the square thing on this one. But we can tell right off the bat that new 0 for x is 7 and new 0 for y is 3, so we have a vertex at 7 and 3. We could just fill that in even without drawing anything. But then just be careful. It's always good to at least draw it or at least picture it in your mind of what's going on here. The focus is here. If the x part is squared, we know this will go up. It's like an up type parabola instead of like a sideways one. There's no timesing on negative anywhere. It's not like negative 20 times anything on the other side. So it's an up one, not a down one. And we know the focus, let's see here, that's going to come down to the 20. So once again, if that's 20, here, let me draw the vertex. I forgot to draw the vertex. That's 7, 3, right? So 1, 2, 3, 4, 5, 6, 7, and then up 1, 2, 3. There we got ourselves a vertex is at 7, 3. Okay, and then the focus will be found by if we take that 20 divided by 4 again like we do. That tells us 5 steps to get to the focus and 5 to the directrix, just like before, but this time we're dealing with an up and down parabola. So we'll go up 2, 3, 4, 5 to get to the focus, locus, and then down 5, 1, 2, 3, 4, 5 to get to the directrix, and that's the directrix line. Boom. If that's the case, then we'll say, okay, I think we could do everything we need to. The focus we found, here, let's just say what it is. If the focus is, how many steps over is that? 7 steps over. That's 7 steps over from the vertex. And then how high up was it? The focus, or the vertex was 3, and then we did another 5. So 8, I guess. So our focus is at 7 steps over still, but then 8 steps up. And then the directrix, that's the line that we're dealing with down here, and we just got to pay attention to how far down it is. It's a y value this time, so we'll say y equals something. In this case, it's the y value of 2 steps down. So we'll just say y equals 2. They already have the y equals part there for you, so you can just say 2, although it's negative, I guess. So negative 2, and then you're done. If you wanted to draw a good picture of it, again, that's where the 20 comes in, because then you say, well, that's the focal diameter. If I have my vertex, I know how wide to draw this thing based on the idea of saying, well, by the time I get up as high as that focus is, I should be 10 steps to the left and 10 steps to the right, making a total of 20 steps, and that way I'll know how far out to draw this thing. Whatever, though. Anyway, and part D is like part B, and then let's see, what else? Find an equation of the parabola that is a focus of 512 and a vertex at 5,7. So they're giving us a focus and a vertex here, and that's it. And so, let's see here. If we're to draw this, we have vertex is at 5,7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's our vertex, and then our focus is at 512. So that's 5 over, and then 5, 6, 7, 8, 9, 10, 11, 12 steps up. And so if I were to draw that in, we have indeed focus and vertex. The vertex is down there, the focus is up here. And then what's important to know about that is, remember, if the vertex is the one that's downstairs, that's the lower one, and the focus you go up to, that means this parabola is kind of an upward parabola, where the focus is on the inside, because that's what a focus is, it's the inside dot. And so then we could expect that, say, that like the directrix would be several steps down from there. And so, well, let's go ahead and do that real quick. How many steps up was that focus? This was at 7, and then up to 12 should be 5 steps, right? So 7, 8, 9, 10, 11, 12. 5 steps up to get to the focus, so then it'll be 5 steps down to get the directrix. So then 1, 2, 3, 4, 5 steps down. Puts us at the directrix right there. Looks like I'm at a y value of 2, I guess. Yeah, that should work, because we were at 7 and we took 5 steps down, so we're at 2. So we could already actually fill in the second part of this question. They say, find the equation of the directrix, and it's just a y value of 2, and that's taken care of. Now to find the equation of the parabola in general, we know part of it already. We know that the vertex is at 5,7. That takes care of a lot of it. We also know, because of what they told us about, because we're kind of picturing how this will go, it's an up and down type one. So if it's up and down, remember, if you watch the intuition video, you'll remember that that means the x part is what's squared. And so, let's see here, that means we'll start out with the squared part. We go x minus, and then looking at the vertex is 5,7, so the x part of that is 5, so we'll say x minus 5. And then the x part is the squared part, so put a square on that. And then equals, and then I don't know what number goes here yet, so we'll put a blank there, but I know that the y part is, let's see here, what's the new 0 on the y part? That's 7, so y minus 7. And then we're basically done, because as soon as we get there, we already know pretty much what to do. Just remember that if I know the distance or the number of steps it took to get to from the focus to the vertex, that was 5 steps up from 7 to 12. If that's 5 steps and that's 5 steps, then long story short, if you look back on the intuition video, 4 times that much will be the number that we throw in next to this stuff. That's our focal diameter. So this is 5 steps, so 4 times that would be 20. So another 20 coming in our way. So we have x minus 5 squared equals 20 times y minus 7. And then as soon as we get that where it looks like y by itself, then we'll be able to shoot that in the answer box there. I'll help you with that, though. Anyway, that's the basics of this for now. And then if you want to get an accurate drawing of this thing, that's why we look at that focal diameter number, the 20. Again, that's going to be, if it was 5 steps to get to the focus, then by the time I get to that focus, I can draw 5, 10, and then 5, 10. Makes 10 and 10 is 20 steps across for our focal diameter. And then we'll say, I know where to draw this. Here's my vertex, drawing it up until I hit both ends of the focal diameter. Boom. And that's how wide to draw this thing. Nonetheless, though, we got to figure out how to get y by itself for our equation. So I'm going to keep the equation and get rid of some of the drawing while we figure that out. Let's see what we can do about that. Okay. Because you'll notice that in the answer box, they say y equals something, and that's not what we got right now. It doesn't say y equals in our version of the equation. So let's do that. Noticing down here at our equation, we have a 20 timesing with everything. Probably to get the y by itself, I'll divide the 20. So then we'll have x minus 5 squared. I'll divide that by 20. And then we'll have just y minus 7. Because if we divided the 20, it'd be out from both sides, or it'd be out from the right-hand side. And then the only thing to get the y by itself then is just get the 7 out of there. So it's a minus 7, so we'll plus it to both sides. But what that looks like is essentially y, and then it's x minus 5 squared over 20. And then after the whole thing, just put a 7. And that's looking good. It should take it like that. If they don't like it like that, you might have to get the bottoms to match on the fractions, put the 7 over 1, and then make it over 20 or something. That doesn't sound real friendly, though, so I'm going to suggest maybe just try it like this. Giddy up, and then let's see here. Oh, yeah, so here's one worth looking at. Kind of a weird question. So they say, identify all this stuff. And so it's funny enough because this thing, the equation of the parabola they give you is not real intense looking. It has like decimals, but there's no pluses or minuses in it. It's just 37.6x equals y squared. That's my version of it. And so, I don't know, I guess, let's see, they're asking for the focal diameter. That's just 37.6 because that's the number that's timesing with the x there. This one has the y squared. The y is the squared part, so if it becomes relevant to us, the y being the squared part, this is a sideways parabola, so we'll have to keep that in mind. Things, though, that we can fill in without doing anything, though, you'll notice there's no there's no plus or minus on these things. There's no new 0 to consider, so the vertex is just at 0, 0. It's a 0, 0 vertex because there's no x plus this or y minus that. That'll be cool. And then we probably have to draw it to know anything else about this. And so, or at least picture it, or I don't know, you could do it by formula as well, because it's dividing things by 4 and all that. Anyway, so this one is a y squared one, so it's sideways. There's no negative, so it's to the right. So we'll expect it to go to the right. And then, let's see here, what else do we know? Well, oh yeah. So if it's timesing by 37.6, if I divide that by 4, that'll tell us where to find the focus, because we'll go that many steps inward to the right, and then we'll go that many steps outward to the left to get the directrix line. Now, 37.6 divided by 4 is weird, but it's 9.4 by the time you divide it. So that tells us Okay, so we're going from the origin at 0, 0, where the vertex is, 9.4 steps to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9-ish. There's 10 or something. Anyway, so about 9.4 steps to the right is our focus. And that already we know some coordinates on. And then, but before we get that, we'll also do the directrix. That's 9.4 steps to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-ish. And then so between 9 and 10 is 9.4, and there's our... So something weird happened, and I accidentally paused this, so I don't think that some of this was in... Oh my goodness, I did it again. So, once again, 2 times in a row, I paused the recording on accident. Oh man, 3 times in a row, I paused the recording on accident, and I don't think all this stuff was there. Oh man, you guys missed some of the discussion. So let me summarize what happened. Okay, I think where we left off was there. We had our vertex in the middle, and then we had some rough cut of the drawing, and the focus was 9.4 steps to the right, and the directrix was 9.4 steps to the left. So then to find that, okay, the vertex was 0, 0. And the directrix line is just defined by its x value, because it's an up and down line. So we'll just say x equals negative 9.4 is all you would put for that. Since they already have an equal sign there, there's a good chance they may not want you to put x equals. They may just want like negative 9.4. I don't know. Try it both ways. Sometimes you got to put the x equals because it's a line that you're describing. And then here's the other weird new thing, or an old thing, whatever. It's the axis of symmetry. That is the line that cuts this parabola in half. And since it's a sideways parabola, it'll get cut in half by a sideways line. And so if we were to look at this thing, here's our parabola as a sideways parabola. The line that cuts it in half is just the x-axis in this case. And so you could say x-axis, but it has an equation for the line. So remember, a sideways line like that, it's defined by its constant y value. And so we could say, a line like this, it's not up in the positive part of the graph, and it's not down in the negative part of the graph. It's right in the middle. And so what's not up and not down is 0. It's not positive, it's not negative. So we would say this is a line that has a y value of 0. And that's what we would put for like the axis of symmetry here. Although I'm noticing the same thing about the equals. So if they don't accept it when you put y equals 0, maybe just try putting 0 and see if they like that better. Anyway. Yeah, giddy up. Or, something.